at the Golden Door. My name is Kathy Van Ness, and I'm very excited tonight to be with Brian Keating. It's an interview I've looked forward to for some time to be able to do. And this is Astrology Week, and we're going to be talking about looking back at the time of the Big Bang and what do you see? And we're going to be asking some really interesting questions about his work and what that means in the theory of the beginning of the, I would assume, Earth, right?
The universe.
Of the universe, even bigger.
That's right.
So Brian Keating is an astrophysicist at UCSD Center for Astrophysics and Space Sciences. He's one of the leaders of a collaboration responsible for building a telescope and an observatory called POLARBEAR, perfect name, that allows physicists for the first time to measure the gravitational waves that emanated from the universe during the first moments of its creation. Brian also co-leads a separate collaboration that detected large clumps of galaxies. I have goosebumps about this. I think it's really interesting. A way of using the CMB, not even going to go there, as a backlight to reveal structure in the universe. So the first question is, Brian, you created a telescope that captured traces left over by cosmic inflation. It happened 13.8 billion years ago. What was the process and how does that feel?
Well, thanks very much. It's great to be here. What I like in this too, what I do is a form of archaeology. So just like Indiana Jones gets to look for things that travel through time, what I'm looking for is stuff that traveled through time too. Except I don't get to look for a dinosaur bone that's been traveling through time and space. I am looking for things that only come to us in the form of light. So I call myself a light archaeologist. So we're looking for ancient photons, ancient beams of light that really are the earliest pictures of the universe. I call it the first ultrasound of the infant universe. So what we wanted to do is I've always wanted to study the biggest things that you could study about science, and that's what my passion is.
So when you were a little boy, how did you get here?
Yeah, so I was saying over dinner that when I was 10 years old, my mother was my first scientific funding agency. She bought me a telescope. There was a really cute girl that lived down the street. And, no, that's a joke. And I was always wondering, what was that bright star next to the moon? And I said, it's got to have a name. And this is before the internet, 20, 30 years ago, before the internet. And I had to wait till Sunday afternoon came, and I got the New York Times Sunday magazine section. I could look up, what was that? Well, it wasn't a star. It was another planet. It was the planet Jupiter. And it just blew my mind that I could see another world with my eyes. And then even more amazing was to see the moons of Jupiter, which inspired Galileo, my hero scientifically, and see those very moons that he saw. It quadrupled the number of moons that I saw in my entire life in one instant. And that just took my breath away.
Oh my gosh. Your discovery captures the question that's been asked time over time of what was this vast explosion? Can you explain for us, because this is an astrology week and we're all fascinated by the planets, explain the actual moment of the Big Bang that created the universe.
So I always say, if I could go back in time to any moment, it would be back to the beginning of time. But what's amazing to think about, the more that we learn about the very origin of the universe, the genesis of the universe, if you will, the less we really can comprehend about it. Because at that very instant, time itself was created. So time did not exist before this instant when the universe came into existence. Unless some other phenomenon, unless there's multiple copies of our universe, which maybe we can discuss. There may be, just as there are multiple planets.
That might be another night. That's next astrology week.
That's right. We'll do Multiverse week. Right. So just as there are multiple copies of planets that could be just like the Earth, there might be other copies of our universe, just like our universe. And so that's the question that drives us to this day. So can we comprehend what took place at the very instant of time? Possibly not, unless there was a universe that existed before ours.
So I'm going to actually follow up that question. Can you actually describe, which you answered, but I'm asking you again just to make sure, the first moments of the Big Bang or the last moments?
So the first moments of the Big Bang, after time equals 0. So if you ask, what was the universe like? We understand the universe not at that first 0 seconds, but we do understand it 1 second after the Big Bang, which sounds pretty good, especially when you think that the universe came into existence 13.798 billion years ago, 798 million years ago, plus 13 billion. So if you think about that, and we know everything that happened back to 1 second.
So what was that 1 second?
So that's the question. So we don't know that. We don't know what happened right before that, where our knowledge ends off, is 1 second. It's like you're doing you're doing ancestry.
Right.
You're doing your family tree, and you get back to that ancestor, and you can't go beyond that. Well, we're greedy. We want to go beyond that, but you can't do that with light, with visible light, or with microwave light. So I invented this gravitational wave detector using a telescope to look possibly back not just 1 second, or not just 1 millisecond, or 1 trillionth of a trillionth of a trillionth of a second after the Big Bang. That's what we want to look back to. An incredible cauldron of seething particles and energy fields.
So you can actually see this?
If we can detect this signal with these telescopes that we're building and deploying all over the planet, literally all over the world, we will be able to glimpse the conditions of what the universe's infancy was like. That first trillionth of a second. In that, what happened? What was the particle like? What was the energy like? What was gravity like? We don't understand anything about that now. So I liken it to this ultimate quest to take the ultrasonic image of the embryonic universe. We just don't have the capability until we build these telescopes.
Well, during your presentation about the mysterious universe, which it clearly is, you mentioned there's a startling possibility that our cosmos might just be the most insignificant speck of what is now called the multiverse.
Multiverse, that's right, yeah.
Can you explain?
Yeah, so the multiverse is a controversial extension of a well-understood aspect of physics, which is that if you have this explosive origin of the universe called the Big Bang, it might not be possible to shut it off. It's not like you run out of gas and the universe stops creating. It may be that the universe is continuously created in different parts that we can no longer see because they're so far away from us. But given enough time, we may be able to see those regions of the universe. And with our telescopes, we may be able to see not only those other universes, but the conditions of our own universe at a very early time. So the multiverse is really a simple extension of what Galileo did 450 years ago. He saw moons going around Jupiter, and he knew they were moons. So he said, the Earth is not the center of it all, as the Catholic Church and others held for thousands of years. Einstein believed that even much later. Not that the Earth was the center of the universe, but that the universe was infinite and static. But Galileo showed incontrovertibly that we are not the center of the solar system. So if we're not the center of the solar system, we're not the center of our galaxy is not the center of our universe, why not let it be at least conceived that there could be other universes?
So I'm going to ask this question a couple times because I'm so curious. You have this telescope.
That's right.
That's in the middle of the highest desert, which the first question would be, was the desert atmospherically a better place than another, and what was that reason?
Right, so people always say, well, why did you go there? My wife always asks, why did I go down to Chile or the South Pole, right? Why can't you stay in Julian or stay in the Golden Door?
We have some space, 600 acres, right?
That's right, that's right, and you have delicious dark matter dessert. So what I always say is that even though San Diego is a desert, there's still an awful lot of humidity here. It rains here, right? In Chile, it never rains. It doesn't rain at 17,500 feet. Of course, there's not much oxygen there either, and you have to carry oxygen tanks on your back like a scuba diver in order that you don't pass out half the time. So you have to go to these great lengths because, as everyone who has a microwave oven knows, I know there's no microwaves here at the Golden Door, but if you have a microwave oven, what's happening is that microwave heat is being conveyed to water inside the food. There's actually water inside the food, which is why you can heat up a coffee inside of a ceramic mug, but you can touch the mug, but you can't touch the coffee. It would hurt you. Right, so water absorbs heat. So you want to go somewhere extremely dry. The driest desert on Earth is not the Sahara, it's the Atacama Desert in Chile.
Wow. Now, have you actually been there yourself?
Yes, I have been there, yes.
And have you actually looked through this telescope?
Yeah, so you don't look through this telescope.
There's the question.
Once you get beyond a certain level of astronomy, they don't let the astronomers put their eyes up to these telescopes, nor could we see the information that this telescope detects. This telescope detects with these very fanciful detectors that look very different than the human eyeball. These are detectors that we make that are cooled down almost to the limit of cooling. And these detectors can sense things that our senses don't have. We don't have a sixth sense to see microwaves and radio waves. But these pieces of technology that my young graduate students that they built, they allow us to see the invisible. And that's what we do. So we don't look through the telescope. Computers look through the telescope. And then we analyze the data that the computers present.
Right. So you've said that telescopes help reveal the origin and composition of the universe.
Correct.
And let me quote you, exquisite precision. Can you elaborate?
Yes. So I liken it to this. So it used to be, when I was just starting out in graduate school, say 25 years ago, it used to be that we didn't know if the universe was 10 billion years old or 20 billion years old. Now that might be flattering. You meet somebody and you say, yeah, you look, you could be 20 years old, you could be 40 years old, right? I'd be flattered by that. But we now know the age of the universe to the same precision as if I look at somebody in the audience who's, say, 50 years old, and I say, you were born on this day at this hour and this minute. That's how precisely we know the composition, the properties of the universe. And this is really a magical time in human history when we can understand things this exquisitely. And don't forget, all the information, we had to wait 13 billion years for it to come to us.
Right.
We don't go out and do an experiment and twiddle some knobs. We have to wait for light and heat to travel across billions of light years to get to us.
So that's an interesting sort of follow-up question. As the telescope is peering into this universe, the data is obviously data that's technically older data, because it's taken all this time to get to you.
That is exactly right. So when you look at the sun, don't do it, please. I'm a professional astronomer. Don't look at the sun. But when you are seeing the sun, it has taken light 8 minutes to get from the sun to the Earth. So for all you know, on a sunny day, you could be looking at this beautiful sunrise, sunset, and that sun could have disappeared 8 minutes ago, 7 minutes ago. And you wouldn't find out about it for 8.3 minutes. And then all of a sudden, all hell would break loose. I hope that doesn't happen. No. Pay your bills before that happens. Keep paying your taxes. But it's the same thing that's a consequence of Einstein's famous theory of relativity, which is that nothing goes faster than light, but light travels at a finite speed, 186,000 miles per second. So that, if you translate that into something a little bit more reasonable, that means 1 foot, it takes light only 1/1000,000 of a second to travel this far. So that means every foot something is away from you, you're seeing it when it was 1 nanosecond younger. At which point, when I'm giving a talk to older audiences, people in the front row start moving back because they'll look younger to me. I wish I could patent that as an anti-aging.
So that's sort of like the age-old question too. If you have this very long time to get this data,
yes.
How far can the telescope peer into the universe?
It can go back to the very beginning. So with this type of telescope, if you arrange and analyze the data properly, there's nothing that stops us from going back, not to beginning of time 0, but to a trillionth of a trillionth of a trillionth of a second, one that's after 36 zeros. So just an incredibly finite, infinitesimal amount of time. At which point, we know that space has quantization. We know quantum mechanics, we've heard of that. But maybe time is quantum. Maybe time, we see time as a river in all cultures and languages. Time is visioned as a continuum, as a river in Buddhism and other religions. But what if time is quantized and we just perceive it as moving continuously, but it's actually making quantum jumps? And in between each jump, a finite number of things can happen. It's mind-blowing when you stop to think about it.
It's fascinating. You must like your job.
I do. I love it. I say,
I think it sounds like I like my job. I love my job.
Don't tell Governor Brown, but I would do it for free.
Exactly.
I'm a state employee.
Don't you just love being able to look at all this?
I get paid to do what I love.
It must be. Do you actually get to see things besides numbers on a computer page?
Oh, absolutely. Yeah, I get to work with hardware. Meteorites. Here's a meteorite. This meteorite is 4.3 billion years old. You can touch it. I
want to touch it. Don't you want to touch it?
This is people think about diamonds and
oh my God.
I know you had a pearl expert here.
Yeah,
but
we did.
This is my gem. This is my
How'd you get this?
Billion years old. So I bought this. I acquired it in the ancient technique of exchanging money for it.
You must.
But look at the structure of it.
I want my guests to be able to touch it.
Yeah, I will pass it around. It has a beautiful crystalline structure, which can only form in 0 gravity.
How did you get that?
So I bought it. You can buy these meteorites. I'll sell you it for the right price.
I'm sure.
So this object can only form in 0 gravity, and it's the age of our solar system, which is 4.3 billion years old. So you're holding the oldest history of our entire solar system.
Oh my God, we have to pass
Star
this around.
stuff. This is what the universe is made of.
How many years again?
This is 4.3 billion years old.
4.3 billion years old.
Yeah.
Let's
so
pass this around.
Yeah, we can pass this around.
Yeah, throw it.
Yeah,
No,
no,
I wouldn't
no.
do it to you.
It's a lot heavier
No,
than it
it's
looks.
actually quite heavy.
Yeah. And this is something that's quite light. So you asked, do I get to go?
Oh my gosh,
See how light that is.
What's this?
This is a piece of Antarctica. So this continent is unlike any other continent.
This is like lava. Yeah.
This is lava, exactly. So pass that around too.
So the polar bear, I want to ask you a different
Yeah.
question. This is just I hope you find this as fascinating as I do. This is just fascinating. The polar bear is something of a time machine.
Yeah.
I think there's a movie, right, that's coming back out, right? Lifetime, the Time movie. There's a big honoring of it coming back. The polar bear is something of a time machine that you created. Explain the concept of how you see time reversing, and what does this actually look like?
So people, they think about time reversing and how you could possibly travel through time. What Einstein showed is that we're all traveling through time. We're all traveling through time at the speed of light, if you will. But because we're made of material, we can't go the same speed as light. We have to go much slower. But relative to our vantage point, we could see phenomena that appear to be slowing down in time. So that a second to you, Einstein used to say, a second on a hot stove feels like an eternity, and 5 minutes with a beautiful girl, okay, it was a little sexy, but 5 minutes, it feels like a second, okay, and that's true. I can attest to that, being married to a beautiful woman. So it is true that time is relative, but not just human perception. And that's the thing, people say everything's relative, but it has a very different meaning to a physicist, and it's very precise and very concrete. But the thing is that this, 100 years ago, would be considered magic, and now we think of it and interact with it every day.
I know.
It's reality.
I know. Explain the difference between polar bear and bicep.
Yeah, so there's two telescopes that I'm a part of, and none of these are done just by me. They're done in collaboration with mostly young people, graduate students, young men and women who are getting their PhD degrees with me in my laboratory, or at Berkeley or Caltech are the places that I collaborate with. So the technology differs between the POLARBEAR telescope, which is the world's highest cosmological telescope in Chile at 17,500 feet above sea level, and BICEP is a telescope at the South Pole. One is a very large telescope, 12.5 feet in diameter, enormous telescope, hundreds of thousands of pounds in total mass. And then the BICEP telescope is relatively big, but it's only about a foot and a half across in diameter. And it's called a refracting telescope, and it's actually fitting. It's very similar to this type of telescope, which I'll pass around. This is a Galilean telescope. This is the exact same kind of telescope that Galileo first used. He didn't invent it, but he first used it to look at the moon and the moons of Jupiter. So we can pass this around too if you like. So this is the type of telescope that's at the South Pole. This is like BICEP. And the reflecting telescope with a mirror, like a giant shaving mirror, that telescope, as it magnifies, so does POLARBEAR. And that's how that
But to make this even more interesting, then there's the Hubble Space Telescope that claims they can peer back and look at galaxies moving towards us and moving away.
That's right.
So for us novices, novices, those are three sets of telescopes. In an understandable answer, what are the three of them looking at?
Yeah, so the differences are like the differences between an X-ray, an MRI, and a photograph. So if you see a photograph, that's done with visible light, and you're able to make out things and they're normal things, but it's only able to see the surface. An X-ray can see through something in 2 dimensions, so it can take all your bones and project it onto a flat piece. But an MRI uses radio waves, and so it can see 3-dimensionally. That's why you can see into the body and see where there's problems, hopefully, some minor problems. So you can see inside of it. So with radio waves, you can see the depth of something. And so if you like, we're looking at the depth, we're doing tomography, we're looking through the past history of the universe. Hubble sees things on the sky, and it looks like it's only a 2-dimensional image, like of a galaxy or a cluster. But just as you can do different diagnostics with X-ray versus an MRI versus a visible photograph, so too these 3 different types of telescopes reveal different science. And we astronomers tailor the technology to the science that we're targeting. So you have to know a little bit about what you're looking for.
So when you look into the galaxies, do you see things that we should know that have changed?
Yes, I can't speak about the alien autopsy, but what I can
Or Mars. What's this conversation that there's water on Mars now?
Yeah, so people are very interested in water on Mars. I have my theories about why people are interested in water on Mars. First of all, I think people like to think about what would happen after Earth. So where could we go if we, God forbid, did something to the Earth, right? So that's one thing. And so you'd like to think of maybe going to another planet. And Mars is the only habitable planet, we think, in the solar system. that has temperature about the same temperature as the Earth, within a reason, and potentially could have water in ice form, and we could use that water to make hydrogen and oxygen, which when combined together explode to produce rocket fuel. So once you get to Mars, then you can build rocket fuel, and then from Mars you can explore the rest of the solar system.
Do you love this, really? Right? Who would have thought? Do you, during your day as being an astronomer, what is a day like in the life of an astronomer?
Mm-hmm. So most or many astronomers are also professors. So I'm a professor, which means that I have the world's hardest 3-hour-a-week job, because that's when I teach. I have 3 hours a week of teaching, and then I meet with students. But really, professors spend a lot of their time, unfortunately, have to do a lot of mundane things. We have to look for opportunities to raise money for our research, and because the government budget being what it is not so high, so we spend a lot of time raising money for our employees. So I have 8 PhD students, ranging in age from 22 to 29. And each one of those I have to support, and they have a salary, et cetera, and they're getting their PhD. So I have to find research projects for them to do. I have to cultivate their abilities to write and to give presentations. I teach, and then it's very rare that I get a chance to be with them in the laboratory anymore. Really? And then, so the satisfaction I get is vicarious. So I get to learn about them, what they're doing, and influence their directions when they're still young. And I always say, look, when you're a big professor, you're going to miss these times when you had the freedom, paid by somebody else, me, to go explore your dreams and learn about what is it like to explore the universe.
Do you find that young talent today, that's something that they're interested in? Is that a burgeoning career?
Yeah, it's interesting. I had so a lot of competition right now is not from other universities, Harvard, Caltech, places like that. It's from Google and Facebook, and they want to hire my smartest people. And so, I post mean things about them on Facebook. No, I don't do that. Actually, my proudest thing is when someone that works for me gets a very high quality job, no matter what they want to do. So my competition are these internet companies, these startups.
Is that right?
But I'm very proud to say that I've had students turn down working for Tesla and working for Facebook and places like that to work on these ultimate questions. Because I always tell Facebook will be there in 5 years, but when you get older, you may not have the time or the ability to get a PhD anymore, and life gets in the way. We make plans, and it doesn't always work out that way.
So do you think in our generation that we'll come to some of these answers?
Yes, I think for sure we will know what exactly the first microsecond of the universe was like. I think it's inevitable that we're gonna learn what that was like. Whether it conforms to our expectations is a whole other matter. Whether nature is kind enough to arrange herself in a way that we can comprehend it, that is not knowable. But we will eventually know. In my lifetime, we will know answers to these extremely big questions about the very Earth. But what's beautiful about science is that there's more than one mystery. That one mystery answered allows you to answer 10 or ask 10 other questions. And that's what's beautiful to me, is that I'll never be unemployed, I hope.
No. But do you feel that in answering that question, since most of the answers are in a mathematical state, I'm assuming, will it actually be in a pictorial state? So we as normal people can actually see this event, and obviously it takes graphic artists to put it, but will be enough information to put it in a way that we can go, oh my gosh, that's what really happened.
So we had some discoveries that were on the front page. One of my employees made, for his PhD thesis, he made a plot that was on the front cover of the New York Times. A year and a half ago. So these are mesmerizing images. You don't look at them and say, oh, I understand that the angular powers, but like I do. I mean, when I look at a painting, I see something different than an art historian sees. But that doesn't make it less beautiful to me. And I think people can appreciate it's not just pure numbers or boring. Not that numbers are boring, but it's not dry. When you look at it, you can see there's a beauty because there's a richness in it. There's an organizing factor to it that excites the human mind and mesmerizes me.
So there's a lot of conversation about the future of robotic space exploration.
Mm-hmm.
So what do you think about that?
Yeah, there's a lot. There's a great book by Brian Greene. Mm-hmm. It's actually a children's book, so I encourage people that have children that maybe have read his books but don't fully understand it. It's called Icarus at the Edge of Time, I think. And I have a 4-year-old son who worships.
Well, he must love having you as a dad.
Oh yeah, he says, you're the second smartest Brian I know. Brian Greene's book, he loves it. So this book is about a young boy named Icarus. And he is flying on an interstellar mission. He was born on a spacecraft traveling to the nearest star system, Proxima Centauri. And along the way, he gets, I won't, spoiler alert, there's no spoiler alerts here. But as he gets close to a black hole, something happens. And when I read it to him, he was really enthralled because he started to ask, well, will this boy die on this spaceship? Robots are colonizing our solar system, but there are no people on it. And I think that that's smart. We should send a lot of robots out there. But people like Elon Musk have said, I want to die on Mars. Not like crash into Mars or to die, but to live out the rest of his life on Mars. And he's working hard towards it. And I have no doubt that there'll be commercial space travel. If you just look back, 100 years ago when the Wright brothers made their airplane, if you ask them, are there going to be Airbus 380s traveling between San Diego and London with 350 people on it at 650 miles an hour?
Have you been to his facility in Los Angeles? I'm sure you must have.
Yeah, so I've been
Oh my
there.
gosh,
So,
it's like in the middle of nowhere.
yeah.
I mean nowhere, and there are rockets being built, huge
rocket.
rockets in the middle of Los Angeles,
That's like
in
my
this giant
Disneyland,
factory.
yeah. Mm-hmm.
There's real rockets and giant rooms with computers and people looking in the space on all these computers, and it's like, honest to God, you think it's a movie set.
Yeah, it really is.
And you walk down the hallways, and there's these people working 24 hours a day
Yep.
on rockets,
Yep.
big ones, like way bigger than this
Yeah,
room.
he's like Tony Stark.
It's exactly right.
Man,
He's like
yeah.
Tony Stark. Feels
It's
like
really
that.
happening.
It's really there. Giant, huge buildings with rockets. Oh my gosh.
Yeah.
So, do you see robotic technology taking over work on the ground as much as it would be in space?
Yeah, so already these incredibly advanced sensors. So if you look at these detectors, they're made with precision of a millionth of a meter precision, 1,000 times smaller than a human hair. There's no person that can make these detectors. There's no human being. I don't care, how long they've been here and relaxed for, but if you had one cup of coffee in your whole life, you cannot do what a robot can do. So there are good things that robots can do. They can vacuum floors, but they can't come up with the theories. They can't come up with the vision and the creativity to create. Not yet. But what's interesting to think about, as my colleagues at UCSD have thought about, when will it be that a computer can start to think about itself? And that will start to be a game changer. Most people don't think about themselves, but when a computer does, it could be very interesting. And some people have tried to do two things. Stephen Hawking and Musk is involved with this too, wanting us to be very careful about contacting alien civilizations or broadcasting that we're here. They may already know that we're here, but we shouldn't be going out there and saying, we are here, come, because they're saying, that's like advertising what's on the menu for lunch, right? It could be.
Oh my goodness.
So we don't want to do that, and maybe we don't want robots to get too powerful. But that's kind of far out of what I do. But I do have thoughts about it.
So Brian, what's next for you?
Yeah, so we're working on a couple of different things. One is a mission in space.
Oh my gosh.
So we want to send up 2 different types of satellites, and these are working with kids at UCSD, some of whom are trying to be the first university team to launch a rocket above the definition of space, which is roughly 60 miles above the surface. So we're working on a tiny little satellite, and then we're looking on a huge satellite to study these faint imprints of the infant universe. And once we see it, we're going to be able to go extremely deeply and perhaps investigate things that no one's really thought to ask yet. My students, they're really brilliant, and once they have this data, it allows them to then ask questions which I couldn't have asked, and then to answer those questions.
Oh my gosh.
And they're part of the scientific tradition.
Wow. Well, at the end of all of our interviews, which I think this has been fascinating, I could do this for days because I just think there's so much knowledge out there to try to understand. We always ask our guest to provide a golden nugget for our guests before you go. And so this is going to be an interesting one for you as an astrophysicist. What would be your golden nugget for our guest tonight?
Okay. Well, I hadn't thought about that, but I'll say the thing that is most interesting to me, and as Einstein said, the most interesting about the universe is that it's comprehensible. That's the most incomprehensible thing about it. To me, I always like to say, because people ask me about God and spirituality and how does that fit in as a scientist, and I like to think that spirituality and science shouldn't be oil and water, that there should be a dialogue and not a monologue. And so to the people that are religious, I say, learn about science. Don't be content to just take things on faith, because you may find that your faith is enhanced by having a deeper appreciation for the laws. The beauty of the laws can translate into a deeper faith, I believe. And scientists shouldn't be so quick to cast aspersions on religion. As it is Astrology Week here, I always have to admit that astrology is really the genesis of cosmology, which is my study of the early universe. So we shouldn't be quick to disparage it. Not necessarily that we should embrace spirituality to necessarily become a better scientist, but there shouldn't be a hostility. And so I think that you should encourage a dialogue, because that's the best way to convince people. So I usually say that each side in the spirituality scientific debate should be open-minded.